Let's jam. Let's go, guys. Today is Friday. The date is 14th, huh? Just a quick schedule. Guys, just a quick schedule here. So today we are going to finish up 7.2. Monday, those that did not bring what you should have brought today, as test corrections. Please bring your test corrections on Monday. We will go over the test then. Truthfully, how many forgot their test corrections today? Okay, 1, 2, 3. Okay, so Monday test corrections, please come with them. And then we'll probably, let's see, test corrections, they take about half a class period to do. So then we'll actually do 7.3 then as well, okay? And then let's keep on going here. Let me just check this. There's 5 sections. So 6 sections. Okay, so I'm thinking if that's the case, we'll probably be around 7.4 on Friday of next week-ish. We're good? This is Monday or Wednesday. Friday. This will be the 19th, right? Friday, 21st, about 7.4, maybe 7.5. We'll get there. Hopefully we can do 7.3 and test corrections at the same time. Okay, let's begin. So today we are going to do the ones you have to sort of manipulate it up in order to even start the problem. So last time, let me go back. Last time we did the easy one, is that right? This is 7.2. That's super easy. We added these guys together. It's called the elimination method, and the y's canceled. We're good. Example number 2 is what we had to do. We had to multiply one of them by 3. Then that made opposites right here, because the whole point is make opposites. Then we were able to get rid of the y. Example 4, we had to multiply both of them by different, notice it's different numbers. They don't have to be the same number. If they were the same number, that means they would have been opposites to begin with. And that's no issue there. Okay, and then we talked about the 3 different possibilities of 2 lines on the same plane. So they could be right on top of each other, which is called infinitely many solutions. They could be parallel to each other, which is no solution. Or they could cross somewhere, and that's the one solution eventually. So, and then the challenge problem 2. So if you want to write this one down, if you want to think through this here.
You got a whole book of it.
Oh, you need paper again.
Yeah, Owen needs paper.
Owen needs everything.
Well, sure. So challenge problem number 2 before we get into, so this one is the challenge problem. If, in case you say, no, Mr. Angie, I already know this stuff backwards, forwards, upside down, and sideways.
Oh yeah, totally.
I know the elimination method. I learned in Algebra 1. I know it. So then the fun part here is all yours here. So 2 equations. Notice on the graph, what do you guys say? Yes or no? I think they appear parallel. That's what I think.
Yes, but they can be slightly off.
But you'll find the system actually does have a solution. So the question is this, first of all, so find the solution. And after you've found it, explain why it does not appear to be that way on the graph. It's an easier one. I think the last one was a little funner one. Okay, so challenge problem, there it is. Okay, those of you that still need to work through 7.2, let's jam. Okay, don't you stuck on the challenge problem here. So we'll go to this one here. Example 7, that's where we're at lecture-wise here. So now we got decimals to deal with. Let me see if there's any fractions on the homework. Let's see. Yes, of course there's fractions. We've got to deal with those too. So these are the crazy ones. We're good? We did the basic ones. Now these are the crazy ones.
Can I finish writing down the problem?
Oh yeah, sure.
Sorry.
There it is. Cool. Zunka and Zunka. Okay, example 7. Those that are ready for that one, just to work together. You know what? Actually, let me keep this in, because then I'll know what I said to you guys. Because sometimes I forget. Okay, let's go down the list here. So if you're working on the challenge problem, just say challenge. Otherwise, let's work this out together here. So I see decimals everywhere, and that's no fun. So now the question is, how do you simplify this. Eventually, we need opposites. That's what we need here. So let's go with, I think he's always working on challenge problem here. So Annette, talk to me. What do you think? Which way should we go on this guy? Think back to algebra 1 or maybe geometry about decimals and how do we just get rid of decimals?
Oh, and multiply it by 10.
Perfect. Yeah. Okay. So Annette says multiply by 10. The only thing with 10 though,
Or
it's
100, sorry.
perfect. Yeah. So it's going to only move it once. If you multiply by 100, it's going to move it twice. And then we actually need twice over here. So that's the only difference between the stuff that we've been doing earlier. And now we're going to multiply this by 100. Boom. Landon challenge problem or doing this one?
I'm doing this one.
Okay. And real quick here, can you help me out on the bottom? Same thing on the bottom or another problem on the bottom?
Should be same thing.
Same thing. Okay. The only time that we multiply with the same thing, top and bottom, but we still don't get opposites, is when we get clear the decimals. Okay, clearing decimals means I move this out twice, I get myself 2x. Move this out twice, I get myself a 5y, and I give myself a negative 38. On the bottom, moving everything twice gets me a 3x plus 4y and 104. Dylan, all yours now. The question is, what do I do next?
Multiply the top by -3 and the bottom by 2.
Oh, cool. Okay, so this is where some of the class will do it one way, some of the class will do it the other. Notice we have opposite signs already here. It could be that you can just multiply the top by 4, the bottom by 5, and now we'll create opposites for the y value. We good? Dylan, and you're not wrong in doing so. If you want to concentrate just getting rid of x's, you can do so as well. So Dylan said, multiply the top by how much?
I think -2. No, -3 and the
Negative
bottom
Okay, perfect. So we're gonna do it the Dylan way. We're gonna multiply the top by -3, the bottom by 2, and that's totally fine because the whole point is just to get opposites. Who cares which x or y you get rid of first? So multiplying the top by a -3 produces, and kind of careful here, it's each individual piece has to be multiplied by that. So that's the -5 multiplied by the -3 makes a positive 15y. Oh, help me out here. -38 times -3. 114. Thank you. I'll trust you.
I'm pretty sure.
Okay. 3 times 2 is 6. 4 times, okay, that's this right here. This times this times 2, that's going to be 8y. And then 104 times 2. I think I can do that. That's 208. Boom. Do we have opposites? Yes, we got the x's to be opposites. So boom. Tristan, all yours. Give me the next line.
Equals 322.
322. Okay, awesome. Can you also divide by 23 to see if we get an exact nice answer? Hopefully. Oh, 14. Perfecto. Okay. Tell me if anybody got not that we don't trust the net, but anybody got to second that answer? Oh, good. Okay. Well, 14 is the answer. Cool. Okay, so now the question, real quick here. Now this is the fun question. Which equation do you want to plug into? Do you want to plug into the original top, original bottom, the multiplied top, or the multiplied bottom, or the next multiplied top and multiplied bottom? So we have 6 different choices to choose from. I would not want to plug in back to the original. That's just me. Good. So, Owen, you get to choose for us here.
What now? What's going on?
Original bottom.
Original bottom.
That's that one.
Can we do like the first one, the first change, the second form of the bottom?
Yep, I'll have this one right here. Now we know that Owen will actually say whatever. That was funny. So let's plug in, it's gonna be the multiply bottom right here. So it's 3 times x. Notice I'm just writing it. As soon as I get to the y changes into 14. Dun, 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 dun. All right, 14 times 4. 56? I think so, yeah. 6, perfect. Subtract 56 from both sides. Anybody got that? I don't know. 48. Wow, okay, that's cool, awesome. And I got 16, I think. So even though we solved for y first, when you put into the answer sheet, the x has to still go first. So it's still x, then the y afterwards, and we are done. We're good. Okay, a little bit more complicated, but still pretty cool. Okay, I'm gonna do example 8. I think we're in example 8, right? Okay, next one. That was decimals. We got to do the stuff with fractions now. And here's the fractions. It's going to be x minus 1 over 2 plus y plus 2 over 3 is equal to 4. X minus 2y equals 5. Okay, where we at? Charlie. Da, 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 da. What should we do? What do you think will be the first step in this thing?
When you just times it like x plus 1 over 2 for the, I don't know which one.
Yes, no problem. Let me guide you here. So let's see, the second, notice the bottom problem does not have any fractions. That's the way I like it. Notice the previous problem that we ever had. Look at this. This is fun. No fractions. Decimals, but no fractions. No fractions, no fractions, no fractions, no fractions. Don't like fractions. So how do we clear fractions out of this thing?
You multiply by the denominator.
I think so. We're good there. Let's see, multiply by common denominator,
And
right?
get them to the same base.
And we don't, yeah, we don't even care about the base. We just want to clear the fractions. Who cares, right? So we're only doing this to the top, not to get opposites. We're doing it just to clear the fraction. We're good? So multiplying the top by, I'm gonna go with 6. Is that okay? Multiply the top by 6. Okay, and if you want to put them here just to clear fractions.
Where did the 6 come from?
6 came from the common denominator between these guys. Good question. Boom, boom. Okay, now for this guy, there's gonna be lots of stuff to simplify here. So what I like to do in this one, first change my pin color. So I'm gonna multiply this guy by 6. We're good? Because there's gonna be some cancellation that takes place here. We're good? So how about this? This guy reduces down to 3. And I'm at 3 times, oh, I'm gonna keep it like this. Oh, minus. Plus sign goes down, multiply this. And in fact, you can almost like work with this equation first and then set it back into our system equation. Okay, multiply the other term by 6. 3 and 6 reduce. 2 is good, yep, 2 times y, 2 there. Okay, the reason why I didn't multiply in the beginning is real quick here, class, this little plus sign right here. If it was a minus sign and you just sort of multiply the 2 times y, 2 times 2, most students, what they'll do is they'll get that mistake and they'll only put the minus with the first term, not the second term. So as long as you can kind of keep this in mind right here. Got to be mindful of that one though. That's it. Okay, do we multiply the other side of the equation? Absolutely. This one does not have any fractions. That's cool. So got this right here. Okay, let's simplify this for a long time till we're ready, and then we'll plug it into the system again. So 3 times x, 3 times -1, 2 times y, 2 times 2. I like that so far. Let's see, then simplifying the left side, 3x plus 2y is equal to 1, is that right? No, not, sorry, not equal to, plus 1. All right, Maddie, what do we do next? No problem, we're right here. We're just trying to get x's and y's on the same side by themselves.
Then just subtract the one.
Perfecto, subtract 1. Man, all this work just to start our problem. Have you guys ever done that before? Like you do a whole bunch of work just to start being able to actually start with something. I don't know. Me, it's gardening. You know, by the time you get the tools out and all this stuff, like, okay, now I'm ready to finally start it. Okay, let's bring this all together here. So I got now finally 3x plus 2y is equal to 23. That's all this simplifying we had to do. And I have x. Oh, I like this. Look at this. This is nice at least. I got opposites already, because I know if I didn't, then I'd have to multiply to get opposites again. Boom, let's see. Camille, what should we do next? I won't say just add them together. I won't say that. I said I won't say that, but you can say it.
Oh, okay.
Yes, perfecto. Add them together. Add them together. The reason why, because we have opposites right here already, right? Cool. So how about 4x is equal to 28? X equal to 7. Isabel, did you solve the challenge problem? Okay, we'll take votes on the challenge problem in just a second here. Okay, x equals 7 is perfecto. Next is Abe. Abe, original top, original bottom, multiplied top, or multiplied bottom, which is the same thing anyways. Original bottom. Okay, I'm multiplying to here. So x is 7, that puts in already. I keep putting my plus signs for minus signs today. How about subtract 7, and negative 2y is equal to negative 2, voila, y is equal to 1.
7, 1.
7, 1 is perfect. Okay, so that means these two lines, however they do it, right, they cross at 7, 1. Okay, challenge problem. Let's see if we have the same thing. And then we'll go to some application questions here. Let me do this here. I think this is my last slide. Yeah, so let me keep that. Let me insert a few more slides here. Okay, those of you that did the challenge problem, not going to take, I don't even know the answer here. I just figure I'll just throw something at you guys.
What did you get?
Isabel, go ahead. What'd you get?
Equipment being 300, 350.
Yep.
300, 350?
315.
315. Okay, so let me actually go back to that slide.
Yeah,
Sorry,
that's
that'd
why
be
you
better.
can't see the intersection on that graph, is because that graph is 10 by 10.
300 by 315 is the answer.
Sure.
Not saying this is the correct answer because I don't even know. But yes, and Owen's right. Our graph is only what, 10? Actually, that's 15 right here, right? It's a little bit over 15. 15 by 15. You won't be able to see that here. So that's why graphs, we normally don't use graphs for these things. We do want to do it algebraically, especially if you're talking about wind speed of airplanes, how many gallons of something you mix with another thing in order to produce a certain consistency. And it's not gonna be 10, it's usually gonna be like 500 gallons, right? If you're looking at things here. So we do wanna use the elimination method for those.
Did you just solve it algebraically?
Yeah, what'd you guys do what'd you guys do to solve it here?
I used the graph function on the calculator because
Oh,
I wanted to like see the actual point on the graph and see how far out it was. So I graphed them.
Gotcha, graphing,
I
right?
also didn't feel like dealing with all the weird fractions you were gonna end up with.
No, you don't have the fractions, you just,
Which one did you set
I
equal x or
just
y?
set it to eliminate y, multiply the top one by 12 and the bottom one by -20.
Yeah, okay.
Yeah.
So here's a
You could have just done 3 and 6. Just out of curiosity.
totally
A
cool.
lot easier.
Totally
It's not that
cool.
hard, you just plug numbers in the calculator and it makes you go right.
Uh-huh.
3 and 6.
Yeah, it's using a calculator though,
But again,
and that gives you.
Real quick here, let's come back to it, because this is a cool problem to think about here. So first things first, notice that Isabel, what did she do? She took this piece here and she multiplied this one, right? This one, she multiplied this one. Because you know, if you multiply those two numbers, you're gonna get opposites, right? Like 4 times 3, 3 times 4. You're gonna get 12 either way, right? So that's kind of cool there. Abe, talk to me here. You would have multiplied by what and what?
just 3 and then -6 because 60 is a quicker common denominator.
3 and, okay, so you're saying that will produce 60 for you? So it's really a matter of
Oh, sorry, 5.
least, yeah,
Five, yeah.
getting the least common multiple out of this, right?
Same.
No, not really. Is that what you
Let's
got?
see, 24,
Oh,
36, 48,
Yeah.
60. Yeah, so it's called the least common multiple. And you think through that, and that will be a -5, and that will produce what you need out of it as well. That's cool. Yep. Awesome. Good job on the challenge problem. You guys, super cool. Okay, let's go to example. That was 8, right? We're gonna go to number 9 now. So no, don't need to put all that together. We have something that happens on airplanes that doesn't happen in cars. Since we're in cars most of the time, we don't sort of think about this here. But we have in airplanes, when airplanes fly, they have something called headwind or a tailwind. And what happens there is it actually makes you go faster or actually makes you burn more fuel to go the same speed, or you actually just go slower. One second, let me see something real quickly here. Okay. That's interesting, like that disappeared on me. Okay, so, man, a long time ago, I flew from Fresno to Tacoma Seattle Airport, and a week later flew back for a conference. And so I wanted to test this theory, funnest thing, I might as well find out if math works, right? And so sure enough, you know, this is Fresno and this is Seattle. And as soon as we were taking off on the runway, just as soon as we were taking off, I put a little stopwatch together. I went click, a little timer, and we flew. As soon as the wheels touched the ground, I stopped it. And it was like I think it was an hour and 50 minutes to get there to Fresno, if I remember correctly. It's been 15 years, but that's fine. Okay, then a week later, boom, I go this way. So Seattle back to Fresno. It took me exactly 2 hours. Same path, same everything. They do fly a little bit higher, but that's not going to change much here. So guys, talk to me here. Which way was the wind with the airplane? Going the same direction. See again? To Seattle. Yeah, took a little bit less time to get there. So the airplane's flying. My rendition of an airplane here. Don't laugh.
Well, that's actually pretty good.
Thank you. And so we have a wind that's actually pushing it along.
Can't go here.
Okay, on the way back, the wind is still going this direction, right? And in this case, we could either be expending more fuel to get there faster, right? Or we could still fly the same, except the wind is now pushing you back. So same thing happens here. Airplane flying, you have a headwind, travels 2,000 miles, flying a distance from Massachusetts to Utah in 4 hours, 24 minutes. On a return flight, same distance, traveling same, it only takes 4 hours. So now the question is this, can you find the exact airspeed of the airplane, speed of the wind, assuming they're both constant, they don't change. And this is where algebra is not purely true, because we understand when we do have crosswinds, we do have, what is those things called? Jet streams, there you go. There's jet streams in the air that some airplanes do take off and they hit the jet stream and it's a little easier. Okay, so let's talk about this here. So first things first, this is where we need to get to. So the original flight that took 4 hours and 24 minutes. What's happening is the airplane is flying and the wind is going against it. So what we're gonna do is we're gonna label this as R1 is a speed of airplane. Come on, chicken scratch. Let me show you. I should write better. Speed of airplane. You mean the English teacher writes worse? Okay. This one, let's see, speed of, it's interesting because we don't really talk about wind as being speed. We talk about rate of the wind, but we'll talk about speed because the book talks about it. Okay, tell me if you guys agree. If the airplane's flying this way, the wind is going exact opposite. The wind is actually pushing the airplane back, technically, right? Because if so, the feather in the wind, it would go backwards, right? On the return trip, the airplane's flying, the wind is actually pushing it ahead like this. So now this altogether speed is R1 plus R2. Okay, let's see how we can make this happen then. So I'm going to do this here. Let's see. We have this little thing that says formula for from science. The easy formula is distance is equal to rate times time. Sometimes it's actually called dirt problems because the is right here. So distance is rate times time. And so what we do whenever you're trying to calculate distance, how fast you're going, how long you've been doing it. Okay, let's go for it. Let's plug it in. So the distance to Utah was 2,000 miles. The rate that we were flying at was R1 minus R2. And the question is multiplied by time. How long were we flying there?
4 hours.
Yeah, 4 hours, 24 minutes. Okay, so, oh, bummer. I think it's going to be, you guys talk to me. Let's convert this all into hours. How do you convert 4 hours, 24 minutes into hours?
You do 24 divided by 60.
That's cool. Yeah, have a 4 plus, right? 24 divided by 60. Anybody got that on a calculator here? What is that? Say again?
Yeah.
0.4? Perfecto. Okay, 4.4 goes right here. The trip back, still 2,000 miles. This one's R1 plus R2. And now it's just, sorry guys, 4.4 on top. It's just 4. Okay. Does that look like any equations we had before? I'm thinking we got to do this here to separate the R1 and the R2 and not having a multiplier. Let's do this here. Let's multiply the 4.4 into here. Is it there? Will that work? Yeah, that should work. Okay. So let's go. You guys have to help me out. I'm going to go 2 screens lower. So 2,000 still on the side. 4.4 R1 minus 4.4 R2. On the second one, it was just multiplying by 4. So then it just becomes 4R1 plus 4R2. Are we good there? It's going to be a little bit of a long problem here. So as long as we're, okay. First things first, I don't like the fact that the 2,000 is on the left-hand side. Can I switch it around? Let me switch. Yes. So 4.4R1 minus 4.4R2 is equal to 2,000. And switch this one, and this is 4R1 plus 4R2 is equal to 2000. Okay, I like this a lot better. Okay, I think I can start working with this.
It's 4.4 RT.
4.4, All right, a little bit more complicated than before, but you guys talk to me. What should we do? I'll give you one, can I give you guys one small little hint here? Notice that bottom equation. That bottom equation is 4, and then a 4, and then a 2000. Remember how in algebra we can multiply by a number everywhere, right? But can we also divide by a number? Yeah. So how about this? Let's divide by 4 just to make it easier. We're good, just to make it simpler to work with here. If you divide all this by 4, this bottom one becomes R1 plus R2 is equal to 5. Oh, way easier now. Okay, I think.
No, you have to divide the top one by 4.4, right? So that you have,
We got to get rid of the decimal first.
oh, okay.
So let's get rid of the decimal on top.
Multiply by 10.
Multiply by 10, okay? This is 44R1 minus 44R2 is equal to, wow, 20,000 now. But we still do the same though, right? So I just need to know, let's see, does 44 go into 20,000? Or do we need to simplify it to something different? Or just get a,
No, it
okay.
does not.
shucks.
Yeah, I got an infinite decimal.
It's 454.54 with a line over it. So
Okay.
It's just 454.54.
545, yeah, no, that's not gonna work because we need exact values. So we can't divide 44 into 20. Okay, so give me another number that might do it. 4 would do it, okay? 4 would be nice. Let's go with it here. So 4,
11R1 minus 11R2
Equals,
okay, so 11R1 minus 11R2 is equal to
5,000.
5,000, okay? And let's bring this guy as well over here. So R1 plus R2. Okay, finally, we get to actually starting the problem.
Did you divide it by 4?
Yes, thank you so much. I should do divide by 4. Right there, and this should be a multiply by 10. Let's see. Let me circle these so we know what we're doing each time. Ooh, okay, what do you guys say? Pretty good, tough problem?
Yeah.
Well, we'll find out.
Okay, let me bug people here. So starting over here, I think I finished that side. These are all yours. What would you do? Awesome, I would do the same. Okay, so multiply bottom one by 11. The top, if you want to signify, you can put NC. What does NC stand for, except for North Carolina? No change, right? There's no multiplier to that. So this becomes 11R1 plus 11R2 is equal to, you guys help me out, 5,500 it is, okay. No change for the top. Okay, I think we're ready. Annette, what would you do next? Add them together, you got it. We created the opposites. That should disappear on us. 22R1 is equal to 10,500, I assume. Landon, help us out. Whoa, 10,000, okay.
I don't think that divides evenly.
Oh, bummer, okay. But notice right now, we are at the point that we're actually solving for a certain, we already got to the point of solving for a certain variable, right? We didn't want to chop this into something we did not know. But now that we're actually right here, we are going to have to just give us an answer of some sorts here. So maybe let's go 2 decimal place accuracy on this.
Well, maybe if you don't do that next time. 954.54.
Right?
Yeah, 477.2727273.
Okay, gotcha.
It's probably just 27 if they get around.
Yes, correct. So it's 2727273. The calculator rounded off that little 2. Okay, I'm going to go 2 decimal place accuracy, and we should say this. We should say right here we have a squiggly equal sign, not a real equal sign. Equal sign means exact answer. This we know we have approximated. Okay, R1, we said, hey, what is R1 by definition? Are we almost done here? We actually almost done.
Speed of airplane.
Speed of airplane, okay, so this is miles per hour. Let's plug it,
Why can't the plane just go between 500?
I know,
Why
hold
does it
on,
have to go 477.27 miles an hour?
with 30 seconds. Guys, real quick, 30 seconds left, let's finish it off. So we got R1, we still need to do R2. We're gonna plug it into the easiest equation we have.
Plug it into the bottom one.
That bottom one right here, that's the easiest one. So this plugs in as 477.27 plus R2 is equal to 500. And can you guys subtract that from 500? What do we get?
2.73.
Thank you, Charlie, so much, 22.73 mph. So the final answer to this would have been, we would actually have to say the speed of the airplane is 477.27 miles per hour, and the speed of the wind is 22.73 miles per hour. We good? Done. Okay, and at that point, enjoy the rest of your, actually, no, enjoy your weekend. I'll see you guys on Monday.
Alright,